Hello, YouTube. The Russian newspaper Komsomolskaya Pravda, the one that I often use for my research of various paranormal subjects, had an interview recently with Roman Rykin, an astrophysicist and associate professor at the Altai State University, about black holes, dark matter, the Big Bang, the passage of time and space, and the explorations of exoplanets. I think people who watch my videos will find this interview very informative. No need to agree with the astrophysicist on all points, but listening to what he has to say may be quite productive. Roman, tell us how the universe works from the point of view of modern science. What does it consist of? Approximately 5% of our universe consists of stars, planets, galaxies, etc., all that we can see. And this is exactly the kind of matter that physicists are so proud of. But this, once again, is only 5% of our universe. The remaining 95% is mysterious dark matter, hidden mass, and even more mysterious dark energy. This is something that we have not yet discovered, but there is already very convincing evidence that both of these cosmological phenomena definitely exist. Is there any evidence of this? If we talk about dark matter, then everything is relatively simple. Even 100 years ago, it was discovered that galaxies do not rotate as they should according to the law of universal gravitation and the following formulas of Kepler's laws. As a result, two hypotheses emerged. The first is that we really don't see some part of the mass. The second is that we not at all understand what gravity is, but since then, many other discoveries have taken place in science, and observational and experimental data have been obtained and analyzed. And today, scientists are almost certain that we're not talking about a misunderstanding of gravity, but about hidden mass, mysterious particles that have not yet been discovered, but manifest themselves in a huge variety of different experiments. When can the dark matter be theoretically discovered? I think that this will happen in the next 2 or 3 decades. What will the discovery of dark matter give to the world? First, we will find out how another quarter of our world works. Secondly, so far we can only guess what possible technological applications of dark matter particles are possible in principle. Roughly speaking, everything related to atomic and nuclear physics is discovered either in space or on Earth using accelerators. And all the technologies that we use in various fields today are based on the physics of the microcosm, atomic and nuclear physics. All this is the product of the work, including that of astrophysicists. Therefore, dark matter is fundamentally important to us, not only in order to understand how the world works, but in order to use it with benefit to humanity. The discovery of the universe is conventionally divided into 2 stages, before and after the Big Bang. Is there any evidence that it was there at all? There is almost complete consensus among scientists on this issue, although the very term Big Bang is criticized by almost everyone who understands what it is about. The fact is that there was no explosion in our everyday understanding. There is absolute certainty that our universe was very small, dense, and hot about 14 billion years ago, and suddenly it began to expand super fast. It is this expansion that is commonly called the Big Bang. What will happen to our universe next? Will it continue to expand or will it start to contract? And it depends on what dark matter is and how it behaves, the mysterious substance that makes up most of the universe. Therefore, the most likely scenario is that our universe will expand indefinitely, but at the same time, different variants of this extension cannot be excluded. For example, there may be an expansion that will lead to the thermal death of the universe, or an expansion that will tear apart all atoms. And even in principle, the scenario cannot be ruled out yet. The subsequent compression of the universe. And what will happen when the universe contracts? There are different options here too. There may be compression to a sufficiently dense state and a rebound, or there may be compression in which a second Big Bang occurs. What will happen to humanity with all these development options? On such gigantic time scales of many, many billions of years, and you and I remember that the stage of human civilization is thousands of years, I would not worry about it too much. Can there be any other universes besides ours? And how proven is this? No, it has not been proven, but there are quite serious hypotheses that allow it. For example, there is a hypothesis that whatever a probabilistic event occurs, the universe bifurcates. The event that happened and did not happen exist in different universes. There are hypotheses that the Big Bang is the birth of one of the many universes. Therefore, what is called the concept of the multiverse is a thing that, of course, is poorly connected today with the exact description of experimental data. No, but this is something that is being seriously discussed. Sometimes there are reports of UFOs. Do you believe in visitors from other universes? I would be skeptical about reports of unidentified flying objects as a manifestation of other universes or civilizations. But looking ahead, few serious scientists today doubt that extraterrestrial life exists today. If scientists have no doubt, then why haven't we shaken hands with representatives of other universes yet? The fact is that the conditions for the emergence of life, even of the terrestrial type, exist at many points in the universe. And even in our galaxy, there are plenty of such places. But the probability that this life is highly developed and we could cross paths with this civilization in time and space, and in this case, we're talking about distances of billions of light years, of course, is very small. Anyway, it's very difficult to estimate such a possibility in principle. What are exoplanets, and have the Altai scientists ever discovered them? Exoplanets are planets that are located outside the solar system. They're constantly being discovered. Currently, there are already several thousand of them. Moreover, there are enough of those that are, so to speak, in the habitable zone, that is, where liquid water can exist, where the atmosphere can exist, that protects the planet from harmful radiation. The Altai scientists are not engaged in the discovery of exoplanets. Our field of study is cosmic rays, but we're closely following the topic of exoplanets, and our students even write term papers about them. Do you think it is possible to launch probes to the nearest exoplanets in the near future? It's very hard. The nearest planets that would be interesting to see are light years away from us, and our traditional probes, which have chemical engines or even hypothetical engines of the near future, will fly there for thousands of years. Therefore, the issue of manned flights is practically not considered at all today, except for very exotic scenarios. And the question of launching robots to exoplanets runs into the problem of expediency in terms of costs and getting results soon. What kind of exotic scenarios are these? Among science fiction writers, there are, for example, very highly professional scientists, doctors and professors. They can talk about this topic quite competently. Therefore, those scenarios that allow ships where generations change while it is flying to another planet, or ships where human embryos live with which artificial intelligence should wake up and grow upon arrival, they are in general not really fantastic. If intelligent life is suddenly discovered on an exoplanet, should humanity come into contact with it? There are different points of view on this issue. Of course, you have to be careful. Moreover, I would consider the need for caution not only in terms of the likelihood of encountering a civilization that brings us evil, enslavement, or death. The danger of bringing microorganisms and viruses to Earth, which may turn out to be aggressive and harmful to us, is just more likely. In this regard, by the way, quarantine may also be observed during flights to near space. Therefore, it is difficult to say. We will probably find life, but a highly developed civilization is a big question. What makes an exoplanet potentially habitable? Is it only the presence of liquid water? If we consider Earth-type life, then this requires water, a suitable temperature, and shielding from harmful radiation. Although no one has ruled out that alien life is there and needs may be very different from ours. Can our planet get out of its orbit? What needs to happen for this? Well, theoretically, this is possible. It requires a gravitational cataclysm. That is, something must happen to our sun, and we predict its evolution quite well. We know it. Or a very massive body must arrive from afar, which as a result of a collision with the Earth will bring it out of orbit. But I would not seriously consider such a possibility. We have a very stable configuration in the solar system. Well, if it happens, what will happen to us? If our planet flies away from the sun, then of course the temperature, climate, and most likely the composition of the atmosphere will change on Earth. It's difficult to predict, but I think in this case, the changes will be very powerful and serious. What are black holes? Do they really exist, or is it something from the category of mystical phenomena? Black holes are not mystical at all. We are convinced that they exist and we can observe them. As for the structure of black holes, there are many misconceptions about this issue. However, as Einstein proved 100 years ago in his general theory of relativity, which is the most successful theory in the entire history of mankind, gravity is an anomaly in space and time. It is a curvature of space. And if this curvature is so strong that even an object moving at the speed of light and the light itself cannot leave the vicinity of this object, then we call such an object a black hole. Black holes can be completely different sizes and masses. Small black holes evaporate pretty quickly. But stellar mass black holes weighing, for example, like the sun, have existed for a long time, and we receive a gravitational wave signal from their interaction. In addition, we know for sure that in the center of most galaxies, there are supermassive black holes. Their mass is billions of suns. In everyday life, a black hole is a kind of abyss. Let's assume a situation where a person steps into a black hole. What will happen to him from the point of view of physics? You know, here you need to include the theory of relativity. Fortunately or unfortunately, but without taking this into account, we cannot talk about events such as falling into a black hole. If you observe an object that has fallen into a black hole from the outside, it will slow down and eventually just freeze at the edge of the black hole. And from the point of view of an object that has fallen into a black hole, it will be deformed and torn apart by very powerful tidal forces. So nothing alive will definitely remain there. There is even an astrophysical term called spaghetti, which means a strong stretching of an object that is likening it to a kind of spaghetti. You are studying cosmic rays. What are they and what are they made of? Cosmic rays are called high-energy particles. Sometimes cosmic rays include light with very high energy, the so-called gamma quanta. But most often when we talk about cosmic rays as atomic nuclei that come to us from the furthest space and even from other galaxies. Can cosmic rays negatively affect the Earth? If we talk about the impact on a person and their health, then the atmosphere protects us well. But the impact on electronics that work on satellites and even on airplanes can be significant. So engineers here have to make sure that there are no electronic failures caused by the influence of cosmic rays. What remains a big mystery for you personally in the study of cosmic rays? The biggest problem for those who deal with cosmic rays is to finally find out their origin. Where are the sources that generate them, how they are arranged, and how these particles travel through the interstellar medium? What modern technologies besides the well-known GPS have appeared thanks to astrophysics? There are a lot of technologies that have come from astrophysics and atomic nuclear physics. They include Wi-Fi technology, which was being developed for radio astronomers. We can also mention digital cameras here, because the first CCD arrays were made in order to receive weak signals from space with ground-based telescopes. A huge variety of medical technologies, as well as muon tomography, uses particles associated with cosmic rays to probe large objects such as the Egyptian pyramids, volcanoes, and so on. Some science fiction films show that time moves differently in space. Does it really? Yes, it is absolutely proven. If you go into space and travel at high speed, then when you return, you will be young and all your friends will have already aged. Having studied the cosmos all your life, do you think there is a God? It is a difficult question. Science and religion speak different languages, of course. I can say that when it became clear that our universe was expanding and then the Big Bang theory appeared, people associated with religion were more enthusiastic about this fact, because in this case we can discuss the act of creation. Personally, I do not observe religious rites, but I am not a full-fledged atheist either. Many complain, why spend money on space if we still have a lot of unresolved problems here on Earth? What do you say in response? Thanks to space exploration, there are many technologies available today that save our lives and save our money. What is your favorite movie about space? You know, it's wrong to call it favorite, but I would like to review the film Interstellar in order to delve a little deeper and understand some details of the plot. Well, and the last question, is the Earth really not flat? Exactly. Here's what I want to add, one footnote. Muon tomography is a technique that uses cosmic ray-produced muons to generate three-dimensional images of volumes. Placing detectors inside the pyramid can help researchers identify cavities inside the immensely large and dense structure without any digging or tunneling. Since muons have much stronger penetrating power than X-rays, muon tomography is often used to image through much thicker materials than X-ray tomography. This is what I wanted to let you know today. I wanted you to hear this interview. I think it shows a very intelligent and knowledgeable person, and I'll bring you more insights from the Russian science and Chinese and some from India too, but quite often our media doesn't translate such interviews. Are not interested in them, but I have my own views about our media in general. And not only in the United States or in Russia, but that's a different subject. I find such views fascinating, and it helps those who really want to study ufology, paranormal phenomena, and don't rely on tabloids. In the future, I'll bring you more, like I said. If you like my research, please kindly support me through the links you will find in the description to this video. Please subscribe to my channel. Please like my videos. And please make sure you're notified when the new ones come. I'm talking about videos. And thank you for your support and your attention to my work.